So as we start here, I wanted to call out, so I've put in the chat, and Laura, you may have to repost it, but this is the hyperlink to the notebook that I'm sharing for today. It will later be moved to our standard CDR PSA community location. At the same time, I also want to call out that I will be going into our Code Commons location where all of our other presentations go. So if you're not familiar with the Code Commons, a quick refresher. So for example, let me just get into this first. So today's presentation, my name is Danny Anderson. I'm a member of the user services team on the CDR QDAS project. I've been working here for almost 3 years, I think, on this particular project. I will tell you, others on my team that normally will be presenting to you, they're incredible programmers and they're great at a lot of things. One of the things that I love most about process work is being able to design the pipeline, design the process that we're going to go through. And this conversation today is really, this presentation is, it's a practical guide to Databricks jobs and task orchestration, primarily looking at how to break large processes into tasks and how to leverage tasks. It's a 30-minute session, primarily focused towards engineers and platform users. I do want to say we're going to do a quick refresher on Databricks jobs, but we have done previous training content on them, and these hyperlinks will take you to the Code Commons locations where they're hosted. So if you haven't tried using Code Commons, if you sign into the portal and you have access to Databricks, you should see one button that says Code Commons. Your landing page there will show you all of our previous presentations that we've presented, including a search bar up here. One of the presentations that we did was on streaming jobs. This was from September of last year, but also others that we've done talk about setup, scheduling, and monitoring of jobs in Databricks from May of last year. And we even had a corresponding interactive session. All that content can be found from these locations, and we'll even take you to the original recording or the event page of the original content. So a quick refresher on Databricks jobs. They've been called, they keep rebranding it, but at the end of the day, it's always jobs. It's like Lakeflow jobs, Lakehouse jobs, Databricks jobs, they're jobs. And effectively, per their own documentation, they say that the jobs are workflow automation, providing orchestration for data processing workloads so you can coordinate and run multiple tasks as part of a larger workflow. You can optimize and schedule the execution of frequent repeatable tasks and manage complex workflows. What I would add on to that whole thing is really just a Databricks job at its base is an input that gets one process that gets linked as a task, and it can be triggered. So it's a collection of one or more Databricks tasks. The execution order is going to be well defined within the job. In this particular case, since it's only one task, there's nothing else to it. And then the job will have some sort of programmatic trigger. It can be a manual click. It can also just be a time event. In some cases, you can even have like file load will trigger a process or along those lines. So this is at its minimum, this is what a job is. I want to go into, well, what's a task then? And here's where tasks become a little more, it's where the meat of the whole process is. If the granularity that you can apply to a task is really the strength of the jobs process. So a task is going to be, it's, as they said, it's a building block of the job. So each task has a defined set of instructions. So either it's SQL code, a pipeline, a query. It could be, PySpark, SparklyR, whatever. It could even be a separate job that gets linked in as a task. And then that task or that set of instructions is assigned to a compute cluster. Generally, these would be your job compute clusters. And then based on the instructions provided, it will pull in the required input data, run its processing, and will output data, or it will output even parameters that can be passed on to a subsequent task. So that way you can actually have communication between tasks as you move from compute clusters. So what are the benefits of Databricks jobs? Why do we usually use these jobs? So usually we'll use them for especially scheduling recurring processes. It helps us use, when we're developing our code, we're great on doing all-purpose compute, but those are about 3 times the cost of what really needs to be done because it has to be interactive. It has a bunch of overhead. So when we use job clusters, those are about 1/3 of the cost, which, but is neither here nor there, but it's also just more efficient with like the resources that we're using. Jobs actually will track the history of each time it's executed. I have an interesting case that we'll look at later, and we talked about it in the previous content as well that you can review. The thing is, and I'm not shaming anybody because I'm guilty of this as well, frequently we stop at this level because we are so used to our own way of orchestrating within our own notebooks or our own scripts that we don't realize that jobs are really supposed to take that orchestration piece out. So we can actually use our jobs to make it clearly define and limit our dependencies. We can it helps for modular implementation of processes. Explicitly orchestrating by task allows us to know which thing happens first and second. It allows for additional observability, which we'll show a couple of cases of later. You can start to parallelize your work. You may think that if you're running like a nested, like running you use a %run in a cell in your notebook, that you're actually like using something new, but you're using the same compute cluster and you're stuck with the same resource constraints. But if you parallelize your work, each of those events can actually have, like that code can go onto its own compute cluster and run in parallel. And so then you're saving yourself time at the end of the day. Here you can match your compute needs to tasks. So many of you, I don't know if you've noticed, but when you go to your all-purpose compute, and even when you go to your job compute clusters, you have 2 options. There's a large and an extra large. Not everything requires an extra large. Sometimes, I'm always of the mentality of, just pick the right tool for the work. Everything is set to be auto-scaled. So you're going to get additional worker nodes. It's really more about the size of the worker nodes and primarily the driver nodes. So you can match your compute needs to your task. Some stuff that you can even do is, they have examples of, using a SQL warehouse job or something like that instead. I'm not sure that we have been able to roll that out to everybody here, but we are working on getting everything rolled out in the best ways. And finally, error handling, controlling failures. Had a great instance of it this morning that I'm going to get to later as we close out our session. So when we think about job orchestration, we're going to put together a number of tasks, and we can actually do a number of ways of these dependencies. So let me come down here. One way of mapping these things out with common designs, you have some serial pieces, right? So task 1 going directly to task 4, which goes to task 5. Parallel processing, where you've got task 1, 2, and 3 fanning in to task 5. You can do some forking work where, if task 4, you run a check and you set a parameter inside of it, a task parameter that will read a value. Say you've done some sort of control check on here, and it's got a threshold. So you assign the threshold value to that parameter. Up here, you can have a forking where it goes, if that threshold, if the score is above the threshold, then go on to task 5. If it's below the threshold, then go on this whole other fork altogether. And these things can all be managed within a single orchestrated job, and scheduled and everything else. Just to call out, this running, this explicit run, it can be set. There's some variances in there. You can do if all things succeeded, at least one of these things have succeeded, all this stuff. Your if else statements, with equals, basically resolving some sort of Boolean output. And then if you need to do an event like looping over, we had talked about this at one point in a previous session. If you need to loop over a process, you can assign an array and do a for each, where then you can get a new cluster and execute that program for each item in that array. And now you've simplified a whole chunk of code. So I want to take you through kind of my standard experiences when I write my code, right? Especially when I was brand new onto Databricks and using notebooks, I'm like, all right, I've converted everything over. I've finished writing my code. It's, we're going to call this a job, and we're version 1. The reality is it's really just a single notebook. Now, I don't know if you realize, but your notebooks can hold up to 10,000 cells. So there's just a lot of room for confusion in there. Because it's a single notebook and I'm not doing a job in theory, it's really all running on all-purpose compute. And because it's a lot of stuff, I'm just doing it all on my maximum sized all-purpose. The process, I have it ingest a few data files. It does some QC, apply some transformations. It's a standard ETL process. Joining some new data, final quality control checks, store the final data, output a report. All right, so I'm done, and I'm about to show this to my team, and my team comes back to me and says, doesn't the code need to be run every week? I'm like, are you planning to manually trigger it? I'm like, oh, of course not. My memory is terrible. I'm going to forget every week. So I'm going to use a job as a wrapper of my notebook. And in theory, you have a task, you have a job, you've got a trigger. This is a job. And many of us, and like I said, including myself, we all start from here. Well, then I wrap it up. I send it back to my team for a review, and my team comes back and says, well, can you walk us through your code so we can maintain it as a team? Because, I'm really feeling it. I'm going to end up winning the lottery tomorrow, and I'm going to leave the team in the dirt, and they can figure it all out. So I'm explaining, well, it's kind of like what I wrote there. I load and clean some data from CSV in our workbench. I run some quality controls, all these other things. I was pretty nice. I did include some annotations to help future developers, but the join logic was a little complicated. And in fact, I've got a lot of parts of my code that are just commented out, and I haven't really cleaned it up entirely, but you can figure it out. Now my reviewer is obviously going to be like, how can we write this more manageably? So then, the flash word that everyone always thinks, oh, modularity, all right, more modular. And I'm like, doesn't that just mean more notebooks? I'm like, fine, I can break it out into notebooks. So what I've done now is I've created 3 new notebooks, one for each of the data file ingestion processes, a new notebook that does the quality control checks, another notebook for the final quality control. And, the rest of my notebook itself is mostly orchestrating it, but it doesn't really make sense to have the transformation. Like this is just like one or two cells. Like why make a whole new code? So basically I'm getting there. I would say now I've got 6 notebooks. I'm still running everything on my maximum compute. And you know, you can kind of follow at least the nested run stuff. I don't know if you've tried to look into your logs on nested runs from a job though, and they're not very easy to follow because they obscure a lot of work. At least when you're running it from an all-purpose compute. Anyways, all right, so here we are. This is what I've decided is more modular. My reviewer's taking pity on me. He's like, all right, well, let's break it out. What are we trying to do? What are the dependencies of this process? And so I list out 10 specific steps. 1 through 3 are just ingesting data files. It's going to read the CSV file. So it's dependent on the CSV file existing in the workbench. Input, output, I'm going to output as tables. 4, 5, and 6 are directly, are dependent on 1, 2, and 3 respectively, but that's their only real dependencies. So, and then I'll output maybe a report or parameters or something. And then I've got, this final new data set that I'm going to create. Well, that's dependent on the successes of 4, 5, and 6, which were also dependent on the successes of 1, 2, and 3. And it's going to create a new data frame and a new table. Final quality control piece, final report creation, and then some cleaning up of my org schema. So this, I'm not intending for you to be able to understand every piece in here because I don't think the image really turned out that clear. But what I want you to see is that tasks 1, 2, and 3, rows 1, 2, and 3, basically, were just ingestion. And 4, 5, and 6 were dependent on that. So here I've got like this serial design. And I can have a single notebook that does the ingestion piece of this. And then based on, after it stores it, then you can, and that executes properly, then you can run the quality control on it. Once all 3 of these have had their quality control pass, then, execute successfully, then we can move on to task 7, which is creating the new data set. And you follow those pieces. And then task 8, 9, 10. All this triggered by it's all time-based triggering. The real question here is now, okay, great. We've got our orchestration teased out in our job. Maybe I have more notebooks than I would have liked, right? Like I've probably got 10 notebooks, but I know exactly where, if you think about it, it's not like you weren't doing these 10 notebooks of work before. It was just that they were kind of intermingled in your one massive notebook. So, I would say focus on the number of commands that you're submitting and less on the number of notebooks that are being created along that process. All right, this is looking great. The orchestration is looking great. But let's talk about the compute work now. As I said, not everything requires the heaviest tool, right? So maybe I'm like, all right, maybe these files aren't very big, so I'll just ingest them on the large, and then I'll save my extra large for these things. Basically, and then there's also like sometimes you can pass on a parameter. In our current setup, we're not able to share a cluster between spaces, like a job cluster. So like task 1. Once you finish task 1, you're going to get a new compute cluster for task 4. So like the data that you've cached in task 1 isn't going to be available. However, I will also say that that's kind of a bonus too. Sometimes, we'll run into problems where we've got so much data that we're not even thinking of that's still cached or hasn't been collected yet. So moving on to a new cluster altogether helps give us that clear space, and we just ingest the files that we need as we require them to be present. A lot of this comes down to empirical testing. Just try thinking about what is best for you. I would argue that maybe tasks 1 and 4 could potentially be done on the same cluster and in the same task itself. It starts to muddy the water a little bit. But that's kind of between you and your team and identifying like how granular you want your tasks to be. However, what I will say is if I have something fail in my process and I only have one notebook, I don't know. Like I have to open up the notebook and then try to find out where it was and hope that it's not like actually like that the failure in that cell is directly related to that cell and not something that happened upstream of it. Here, if I have a failure in task 7, I know the problem is with the code in task 7. Particularly if I know that 7's not even going to run if 4, 5, and 6 don't pass. So what I want you to consider is the design implications and value to your team and your future sanity. Because if you're anything like me, I don't remember half the decisions I made yesterday and why I decided to write the code one way or another. Just think about what is going to be in the best interest for the future of your code. I'm of the mentality that if I have to rewrite my code in 6 months, I definitely didn't do it the right way the first time. So we want these things to be resilient, future-proof, not have to come back to it too much, right? And this is something that you're allowed to do. So just in summary, at the beginning, we had a simple definition of like a single notebook, a large number of cells, a lot of processes happening. And if something failed, you had to go into the cell and hope you could troubleshoot from there. Now we've got this orchestrated process as a job. It's cleaner in seeing where the orchestration code is, which, code, it's a UI, right? But the orchestration components of it versus the data processing work. Your failures are easier to identify. This is a snapshot of one of the jobs that we execute as part of the user services team. We run this 2-3 times a day. You can see we've got some pipelines in here. We've got some regular job clusters in here, a few different things going on. Each of these has a notebook associated with each of them, with them. Just this morning, we had a failure. You can see this process overall usually takes, about an hour and a half or so. I can start from the beginning trying to look through every line of code and try to find where my failures were in each step leading up to it. But because I've got this lined up as an orchestration, as a job, I can see, well, my failure was actually right here. I know that this is my failure. I also know that other things that weren't dependent upon this still executed fine. So I don't have to rerun these things. I just have to focus on this step and then this step over here. And this right here saved us, I don't know how much time, honestly, having to go into it, but I was able to click directly into it because I knew exactly where my initial error was at. Additional resources, we're never going to be able to go through everything that Databricks offers, but I do want you to see this was, they have some really good documentation, particularly about parameters and other design options in the jobs location in their document and Databricks documentation. we will be following this up next week with additional features on troubleshooting tasks and best practices in writing out our tasks. And then in a couple of weeks after that, we have an interactive session as well that is on the calendar. Well, it's in our books. I think we've actually announced it on the calendar that we'd love for you to participate in and get some hands-on experience with a couple of common issues that we can, work through. And with that, I would like to thank you for your time.